Welcome, ladies and gentlemen, to Integrated Math 2. In today's episode, we will be discussing Chapter 1.3.1, which is angle pair relationships. And basically, the crux of today's lesson is we're going to determine how to find certain measures of certain angles based on vocabulary that we will be learning in this lesson. And so you can go and read the prompt. It says you're going to be working with certain diagrams in the course. You can assume that lines and segments can appear are straight, and rely on geometric markings in the diagram, so there's no tricks here going on with the straightness of lines. And just basically the top paragraph is telling you all the things that you can assume. So it says certain angle pair relationships come up often enough in geometry that they have special names. Two angles that have a sum of 90 degrees are known as complementary angles. And so they're telling us that since angle ABD, now notice when they name ABD, they're using the path, right? So A to B to D, right? That is a right angle. Now we know that, one, because they told us, but two, because this little box down here indicates a 90-degree angle, so we can make that assumption and know it to be true. It says if ABC, in other words, this angle here, the smaller angle that's in blue, and then this angle here that I've highlighted in orange, if we know those two to be complementary, right, that means that what they're trying to tell us is that they're trying to tell us that angle ABC and angle CBD must be 90 degrees. Again, because the two angles have a sum of 90. So they're telling us that angle CBD is 76 degrees. So they're telling us that this deal right here in orange is 76 degrees. So what I can do is I can make that replacement and call them 70. Actually, instead of 76 degrees, I'll call them 76 because I don't want to keep drawing that degree sign. So from here, we're back to, believe it or not, an integrated one-level problem where all I have to do is just subtract 76 from both sides to solve for the angle ABC. So angle ABC is none other than 14 degrees. And again, how did I do that? I knew that the two angles added together would give me 90. I plugged in the angle that I knew and solved for the angle that I needed. And so a lot of this is going to come down to setting up an equation that you guys will feel comfortable with manipulating and solving for the missing piece. So there you go. All right, so I'm going to go paste in the next set of problems real quick, and I'll be right back. The next set of angles that we need to learn is an angle set known as supplementary. Now, if two angles add up to 180 degrees, they're known as supplementary angles. So if you look at the diagram to the right here with this straight line, it says angle LMN, which is actually this flat line across, is a straight angle. And straight angles by default have a measure of 180 degrees. It says the pair of adjacent angles, adjacent meaning next to, LMP, which is going to be this small blue dude, and then angle PMN, which is going to be this larger, hopefully we can see it, green dude, hopefully we can tell the difference between the two. They will form a straight angle pair or a linear pair. This idea that I'm highlighting in green, called the linear pair, we're going to use that term a lot, so hopefully you guys will remember that. Remember, a linear pair will always be 180 degrees when summed up. So they're saying that angle LMP is 62 degrees. What is the measure of angle PMN? Well, again, it's kind of it's almost exactly like the last one, except instead of 90, I'm going to add them up and have them become 180. So I can say then that angle LMP plus angle PMN is going to be 180 degrees. Again, I believe they told us that angle LMP was 62 degrees. Oops, not B, P. PMN is 180. And as long as I know 180 minus 62, then I think I'm fine. Again, I'm just going to solve for that angle PMN right here. So angle PMN, 180 minus 62, well, that's going to be 118 degrees. So pretty simple. So to sum it up, complementary angles add up to 90, supplementary angles add up to 180. So we're going to apply this into a different kind of problem. So give me a second, I'll cut and paste that one in. Alright, so it says, when two lines intersect, the angles that lie on opposite sides of the intersection point are called vertical angles. For example, in this diagram, angles AED and CEB are vertical angles. Let's go and label those out real quick. Angles AED, so the angle that encapsulates this X where I drew this purple, and angles CEB are vertical angles. So we have to name another pair of vertical angles. Well, notice how the angles are directly opposite of each other. So we could also say, and I'll go and just do this one in black. Oh, the diagram's already in black. So let me do it in green. So here, notice how this angle, AEC, right, could be vertical to DEB. So let's write that down here. So angle AEC and angle DEB. Now notice how this angle E is in the middle. Angle E could have been any one of these angular points, right? It could have been the side, the left side, the top side, or the bottom side. So whenever you have an ambiguous angle where you're like, I can't really describe, what that angle is by a singular letter, then you have to use a three-letter combination and just follow the path. So AEC, DEB. And so get used to that type of notation as well. It says now, using the diagram at the right, find the measures of angle AEC, DEB, and CEB if x is equal to 23. Okay, so they're telling me that this is 23 degrees, and I'm actually going to go and enlarge in this diagram here because I want to make sure that I have enough space for the work. And so from here, this is angle DEB. So I'll go and just call this guy an E right here with a D up here and a B down here. So again, what they're asking us to do is they're asking us to call upon the previous knowledge and make a relationship between these angles. So I'm looking at 23 degrees. I'm looking at the E angle down here, which is in reference to this piece here, right? If I wanted to solve for angle DEB. Well, what's the relationship? We covered it a few seconds ago. This E right here, this angle, and this 23 are a linear pair. And so I know that based on my definition of linear pairs, which we did up here at the second portion of this problem, I know that those angles are supplementary. And what does that mean? That means that when I add them up, they become 180 degrees. So if I can just subtract the 23 from either side, then I think my angle DEB will be clear as day, so 157 degrees. So I'll go and write that. So I'll go and, oops, whoa, I hate when the program does that sometimes. When the pen gets really large, that will happen. So I'll go and say angle DEB is, not 23, sorry, 157 degrees. Cool, so we have that down. So now we have to solve for the other two angles. So I'll go and make a list because I don't want to forget. Angle AEC is something, and angle CEB is also something else. So let's do with AEC next. So AEC, that's going to be right here, right? The A is up here and the C is down here. Well, check it out. I'll go and just throw down another E right here because they're the same, they reference the same angle E. Well, look at this. They have the same relationship, right? So 23 and this E are absolutely on a straight line. They're a linear pair. So I can say angle AEC plus 23 is 180. Now, we've actually already done this problem, and we can say that this is 57 degrees. Okay, so now from here, this angle E right here, we know that he's 157 degrees. Now, from here, I'll go and just call him this angle CEB. Well, look at what kind of relationship they have. I'll go and highlight it in blue here. They have a linear pair relationship as well. So what I can say is I can say that the 157 degrees and the angle CEB will be 180 degrees. And if I subtract the 157 from either side, I'm going to get CEB equaling 23. So, hey, we're kind of back to where we started. Okay, I'll go and move on to the next problem. Take a second and copy that down. I'll be right back. The last thing we're going to do in this lesson is we are going to do the proof of the vertical angles relationship. And so it talks about vertical angles being congruent. And so from here, guys, remember the word congruent means identical, right? The same. And so what they're trying to tell us here is that somehow this B and this C are absolutely the same measure of angle. And if I wrote down a little d right here, the A and the D would be congruent as well. And so from here, how do we establish whether or not this is true? Well, what we're going to do is we're going to use that linear pair relationship that we learned a few seconds ago, or even a few minutes ago, and I'm going to go based off of this thing that our buddy Jacob put down first. So he's going to say A plus B equals 180, and A plus C also equals 180. Well, from here, if I know that A plus B is equal to 180, and A plus C is equal to 180, then what I can do is I can actually take a piece from each of them and say that A plus B is equal to, I'll give you a few seconds to think about what I'm going to write down. If you want, you can even pause it and think about what I'm going to write down next. If A plus B equals 180 and A plus C equals 180, then A plus B will equal... If you were thinking A plus C, then you were thinking the exact right thing, right? Because if one thing is equal to 180 and the other thing is equal to 180, then these guys have to be the same thing. So now what I'm going to do is I'm going to just subtract A from either side. And I'm going to say that B equals C, which is exactly the angle pair that we're looking at. B equals C right here. Those angles which are vertical happen to be congruent. Now actually that can be done again to show that A and D are equal. Let me see if I can line this up correctly. If I can say that A plus B equals 180 and B plus D also equals 180, again, and they do, right, because it's a linear pair right here, then I can say then that A plus B equals B plus D, and then I can subtract B from either side, and then A equals D. Again, vertical angles are congruent. And so we can actually say that to be a rule that we can use. And so we know this to be true now. Vertical angles are congruent. And that will come up, and actually I believe you guys learned that in Integrated 1 and kind of accepted it as truth, but now that we have the proof of it, then we should be more confident in that knowledge. And I think that will wrap it up for this lesson. So good job. Please leave any questions in the comments area, and I will see you in the next lesson.